What is the point? Convey information. What else? Yeah, explore possible relationships. Anything else?
It helps us like show people how to interpret the data in a way that's hard to see with others. So when you see a picture, it's easier to know it.
Yeah, so show non-data people our results. And those are like kind of the three things that visualization does for us. Preliminarily, it allows us to see our data in a different way because we'll see how pictures of our data, rather graphs of our data, convey things that we just would have never considered otherwise. Second, it allows us to paint a powerful picture of results in an internal sense and an external sense. So you can produce some charts that, for example, choose an ideal value of K for cross-validation, where K probably has some minimum where it minimizes error. Remember yesterday's cross-validation lecture. And we could plot the error versus our K value and then determine where that minimum for K should be for our function. That's something very internally valuable for us, just as much as externally. And if you're presenting to someone that's in your data science department, that same chart can be valuable. If you're presenting to people that are non-data people, simplistic and accessible charts are key. So those are like the three key things. Today we'll be discussing it predominantly from an exploratory data analysis perspective. The important thing to keep in mind when we're doing visualization is we want our visualizations, this sounds very intuitive, but it's often neglected, to make sense, right? Like visualizing features that have a story or features that should be represented visually with a line instead of a scatter plot, instead of a histogram, instead of a bar plot. Those are all the types of considerations we'll want to keep in mind as we determine what type of plot we would choose to show some given relationship. So all this, except for like the very last few things, are going to be from Pandas, from the visualization library in Pandas. We can discuss a few of the seaborne functionalities at the end, but the bulk of the exploratory data analysis that you would need to do is highly accessible through the Pandas library. So we're just going to first and foremost import Pandas as we always do, and import matplotlib. Are you all familiar with choosing a different style of plotting?
Like just using a different package?
Yeah.
Yeah, we use Seaborn and Matplotlib.
Yeah. So within those packages, there's also stylistic choices you can make.
Colors and sizes.
Yeah, that type of thing.
I think that's probably gone further into it than others.
Yeah. Okay. So a really common package that I like to use, as well as people throughout data science based on 538's analysis, is called ggplot. And ggplot is a really nice library with good colors and so forth. So if you scroll to the bottom, I actually did this at the end because I like to make it painful. I like to make the business really ugly and then show you can make them pretty. But we'll just start out by making them not so ugly from the onset. So we can ask what styles are available. So we can say plot on our plot library, .style, .available. And here it says we have
dark background, BMH, grayscale, ggplot, and one called 538. So I like using ggplot. So I'm going to say plot.style.use, which is just the declarative way to tell plot which style to use for every future plot. And I'm going to say single quotes ggplot. Great. So now what we've done is imported packages and set our styles. Let's get some data to look at in the first place. The data set we're going to be using is the data set that the World Health Organization compiles on drink consumption, or alcohol consumption rather, by continent and by country. So it's accessible via this URL in a CSV in Pandas and create a data frame called drinks. I also, as you know, the list of strings are the column names that I'm going to use. And if we take a look at like why I did that, we can look at our raw data real quick. What's that? Oh man, I didn't switch. And it's frozen. Ever since I've connected to this display, the colors on my laptop have randomly been changing throughout the rest of the day.
Oh, for me, yeah. Yes, John knew how to fix it.
Like they change and then they go back, they revert, I don't do anything and they change back.
Yeah, you gotta install the settings.
Okay. It's been driving me raw data that we're reading in. We can see that the columns are labeled country, beer underscore servings, spirit underscore servings, wine underscore servings, total underscore liters underscore of underscore pure underscore alcohol, and continent. So something that these labels do a nice job of for us is they're all entirely concatenated, or rather joined by underscores, at the very least. Like this is the word concatenated with this. There's no spaces, basically, which is nice because whenever we refer to a column, we can just say data frame name dot that column. Imagine if there were a space. We said data frame dot beer space servings. Our data frame would look for beer, and we'd be like, what the hell is the servings thing? So having columns that are labeled without spaces is very useful. Despite that, they're quite cumbersome.
So it's besides cumbersome, it's just a principle of tidy data to simplify the column names.
Yeah, and I almost wouldn't even say it's a form of tidy data. It just makes it more easy to use for us. We're not like cleaning the data, so to speak. We're just renaming columns. So yeah, so I mean, I took those columns and named them country, beer, spirit, wine, liters, continent, where I know that these are all servings. Liters means the total liters of alcohol of servings column, and so on. So I'm going to call that data frame drinks. Yeah.
If you didn't have in your CSV file, like if there wasn't already a title row, and you put in columns like this, would it just replace the data in the first row, or?
It would add columns.
And then the.
And that would be like an index. It would treat that like an index row.
Okay.
And then your data would still be below.
How does it know, basically?
Because that's the way it's been declarative written. So unfortunately, it's kind of like the way it is, the way it is. But this is a good discussion of the difference between indices and data values.
Okay.
Let me ask you, are you familiar with the difference between an index and a value in our data set?
An index is like a location, right? Like
Yeah.
it's usually a set of values of some, well, no, it could be the double. It's
No.
like the directions and the values what you find when you get there.
Yeah, yeah, it's like the direct, I like the directions metaphor. It's
I
like,
just feel like in the CSV file, it's just like the row lists the words,
Mhm.
but I'm not seeing any like.
Yeah, so I think an apt parallel is Excel. So if I go to this data set, and this is just like a bunch of Airbnb data. This is what? Is this data? The blue? What is that? Index. So if we said refer to point like the column 0, which column is it going to refer to? Okay. And the funny thing about that is, see, this is a bit confusing because, and this is why it's confusing for you, because you're like, this is a row of data according to Excel, and these are the indices. In Python, these columns, A through, etc., are named based on what we tell them to be named, and those become the indexes.
I just mean in the CSV file, it looks like it's almost a text file, so there's nothing calling out the difference between the index and the actual data. So I'm just wondering how it knows that delineation if there's just 6 separated values versus if it just started with the Afghanistan.
Yeah.
When we put in columns, it replaced that first row.
Right.
If that first row had not been there, would it replace Afghanistan?
I'm not actually sure. I know that if you don't declare any columns, it's going to it'll declare columns for you that are just 0 through 6.
Okay.
In this example, I mean, you could try it real fast and let me know, but I can't
I think
definitively
we
say.
should do this to be able to tell, like, I think Pandas has.
Yeah, I'm like
I
95%
can tell if
certain.
you've got, like, columns
that's the
that are
case.
different to the values under that.
Yeah.
It's just smart enough to do that.
I think so, because that's what we've been doing before.
Which is why what I just said, if you don't declare columns, it just does 0, 1, 2, 3, 4, 5, 6 for your column names.
Unless the data set already has.
Yes,
like,
yeah,
first
correct.
row, which is column headers.
Yeah.
Yeah, I can tell the difference.
Yeah.
If you don't declare columns, it still needs words.
Yep. Yeah, one of the awesome things about Pandas, frankly. Okay. So now we got this data set. First thing we're going to do is make a histogram. And before I do that, what is a histogram? Frequency distribution. What does that mean?
There are bins, and each bin is
What's a bin?
a bar,
Okay.
and each bin is a different height, and it shows the spread of the data according to the frequency of each function.
No, you're there. What's your y and x axis?
The x is well, the y is just the number of values, and the x is
Whatever we choose it to be. Whatever.
they vary.
Yeah, whatever variable we're analyzing. Yeah. So histograms are distributions of our values where the y-axis is always frequency. And then it's always looking for a continuous list of values to plot. In other words, a histogram does not work with categorical versus categorical data because it's going to look for frequency versus categorical, or frequency versus using numerical. But because it's inherently always frequency, it requires a continuous numeric variable, or measurement at the very least. The variable can be categorical, but it's measured by frequency. So yeah, so I'm going to go ahead and order our beer servings column. So that's greatest to least. And you can tell or least to greatest. If you can pass through descending equals false if you want to do the opposite.
Warning, I'm not saying order is deprecated, these sort values.
Which version of Python are you using? Let me look at it later. You should be fine. Did anyone else get that warning?
Yeah, it usually, I mean, it means the function works fine, but then it can change in the future.
Right.
So I call it future warning.
Yeah.
It's just like, in the future, you might want to do it.
Yeah, deprecated means that they're no longer servicing it, or they changed it for additional versions of Python, is what deprecated means. But it's, I mean, inherently case by case, inherently. Okay, so now that we have our values sorted, if we go to histogram, they will appear in a nice sorted way. So the first one I'm going to make is histogram. So I'm going to declare how many bins I have. What is the bin? Yeah, how many like buckets, like groups of values. So drinks.beer, so the beer service column plot. What kind of plot? Excuse me. A histogram with 3 bins. And you can see that our style here. This is ggplot. It looks nice. I'm going to take this opportunity to quickly just switch our style real fast to something else, just so you can see a few of them. So this style, dark background, was made for if you want to visualize your data, but you don't want anyone to look at it because it looks so bad. And then we'll do one other one. Here's 538 style. I'm going to go back to ggplot. You can see how easy it is to call a different package, and that's the point of that. So now, what do you notice about this viz? Is it useful? Is it good? Is it bad? Why?
I don't really know what it is. I'm not sure what's
Okay.
I think the pins are too big for it to give you the pressure and all the data.
I agree with you. So what a bin is a different thing than she said. A bin is saying that for every value that falls between 0 and 100, plus 1 frequency. And she says that this plot doesn't seem very useful because there's too few bins such that so many data points are grouped together. We don't have a true picture of what our data distribution looks like. So let's up our number of bins. That's kind of nice. Tells us more than probably the 3 bins did. And then one more thing we're going to do is, now that we've decided that we like this histogram, we're going to give it some labels. So we'll give it a title, histogram of beer servings, an X label, and a Y label, where the X label is beer servings and the Y label is frequency. And there you go. And there's one other kind of of histogram called a density plot. What is that? Does anyone know what a density plot is? Yeah, let me see the comment what goes super. What does that mean? So I'm just gonna do it and be like, whoa. So what that is instead of bins displaying the true frequency of our values,
it's going to make a line that would connect where our values are, and that line is as bendy as the number of bins is. And critically, it's a density function, which means instead of just being a histogram where it's a line and the y-axis is a measure of how many of those values, like what percent of those values fall under that part of the distribution. So it scales it.
Let's make it and see what I mean.
So you see, so obviously resembles our histogram, but you see here, density. So this is what percentage of the values in our data set fall at that given X value. Why would a density function be valuable when, in the case versus like a histogram?
So it's not scale line where we have to, is that, am I seeing decimal where there's not decimal?
You're seeing a decimal that needs to be converted to a percent.
Integrate over this, you find that probably the percentage that will fall to any given range.
Yeah,
So if you integrate over the whole thing, it should be 1.
that's true. From a visualization perspective, it's particularly useful.
It gives you an idea of the relationship without having to find the right number of bins.
That's true. Yeah,
The same idea as histogram.
yeah. In addition to that, it would more, if we had a normally distributed data set, it would more closely mirror it. So we could plot, say, a density and normal distribution on the same axes and really compare what things look like, which is really useful at the beginning of a data set. When you're like, this is what our data looks like, this is how close it is to normal distributed. That's why I used an average instead of a median, right? Because if you have data that's not distributed nicely, taking an average is going to skew towards where your data is skewed. And that's when you take medians instead to describe your data. But if you have normally distributed data, your median and average should have no real functional difference when you're describing your data. Okay, so now let's do a different type of plot. We're going to do scatter plot. What's a scatter plot? I know you guys have done this.
Dots.
Dots. About what? Yeah, it compares the relationship between two variables, where one variable is the x value and the other variable is the y value. So in this case, I'm going to take two columns from our data frame, the beer and the wine column. I'm going to sort by beer. And then I'm going to scatter beer or wine versus beer, where wine is the y and beer is the x.
So pretty straightforward.
If you don't append values at the end, like you don't use that last line argument, it just gives you a data frame. Is there a benefit to doing an array instead of a data frame? Like you just
When-
take little dot values at the end.
The value of that
Is this calls the exact points we're going to plot and shows us. So not a huge functional difference.
it's illustrative. Okay, so we make that plot, and it looks like this. What do you notice about this plot?
That's good, bad. Yeah, there's a lot of group down the bottom left. There's a lot of group in the bottom left. That's problematic. What is this data of? Remember, everything from visualization should be related back to why the heck you thought that plot might be useful. So connecting the idea of what our data is about versus what you just said, what can you tell me? So what is our data about?
You're in blind dots
For what?
or
Exactly. What?
Was it
For
country?
per country.
Per capita.
Just for it was just I forget how the WHO structured it. I think it was just aggregate and then by liters or whatever unit they chose, but not per capita. So it's servings per country. What now connect this data is about servings per country with we have a high clustering in the lower left portion. What do you think is going on?
A lot of countries.
A lot of countries aren't drinking, and yeah, a lot of countries are reporting to the WHO that they don't drink. So, I mean, there's like a useful insight, right? Useful insight number one that we would have struggled to derive from just doing non-visual insights into our data. Not only that, but we don't have a great idea of really how many countries are here, to your point. We know there's a lot. So we can make our points have a gradient, a transparency level, where if they overlap, they become darker, of course. But if they're just sitting in isolation, then they're a bit more transparent than other points. And the way that we do that is we call for an alpha, where alpha is equal to how transparent each of those points should be. Does everyone see what happened? Does that help?
A little bit. We're not getting the backgrounds, axes, horizontal, vertical lines, it chops up everything. How does that, how do we get that to show up?
You're not getting the grid.
Exactly, same grid.
Are you using ggplot or 538?
Alright, I can ask him.
Okay. So one other thing we can do is change the color per point. And the way that we do that is there's a value we can pass through for C, where C says which value do you want me to color differently? And the interesting thing about this plot that we're about to make is how many values, how many X values are we showing on one graph, one plot rather? Yeah, sorry, there's one point for each of them. But in terms of like our data frame, how many columns are we utilizing when we make this plot? People are saying it, but not loudly. Great. So that's pretty cool, right? Because we have a two-dimensional plot and we can show 3 dimensions of data. And the way that we do that is we're going to color this same scatter plot, but the color is going to be a different columns data. And the color map is, well, what colors do you want me to make these things? We said blues. Oops. So there, 3 values, 1 plot.
Is that working exclusively for quantitative values, or do you do that for categorical stuff as well?
You can do it for categorical stuff, and this is something where I would have to look at the documentation before I can tell you how. But yes, you can. You can color by color, or you can color by category, and not necessarily by quantitative value. I remember I was playing around with this for a second because I knew I was going to get that question. And when I was playing around for a second, I was struggling to make it so our colors weren't a distributed of the categorical value. In other words, the categorical value was still thinking it was a quant value. And that made it so our visualization wasn't useful because it was like how much of the category is a different color instead of saying a category is definitively red, blue, whatever. But nonetheless, you can do it, and I don't immediately know the method.
To make sure I'm making 100% right, you just pick one point out and tell me exactly what it means.
Yeah. Can someone else do that?
Probably.
Oh, you did that.
Make an attempt.
Yeah.
So the core graph, let's just first start with line here. It's still showing clustering at the bottom where neither wine nor beer is. But then the interesting overlay of that is that it's also white. If we refer to spirit, that's because white shows minimal spirit or 0% consumption. So that cluster is actually telling there are a lot of countries that report that there's no wine, beer, or spirit consumption. Maybe they're all about the universe. And then if you go up to like a very, very dark blue point, like the beer 250, wine 75, or beer 200.
Yeah.
So that's telling that there's consumption of 200 servings of beer, I guess, whatever it is. Somewhat minimal wine, 50 to something, but then it's very high spirit consumption because it's not blue if we compare to our right axis.
And so you said this point is saying there's 200 servings of beer, about 30 servings of wine, and about 300 servings of spirit. For what? What is this point?
Country.
Country.
So that's sort of like the Tableau, dragging elements onto color box that show. Is that right? Yeah, that's pretty much it. Okay.
I don't pay for Tableau. I don't know it, but I know that I know we have a subscription, and I've used it briefly, but I'm not very good at it, just because I haven't used it much.
You can probably fit it.
Yeah, I can now from being a GA. But like at work, we're not gonna pay for that. We don't need it. We had it at the place I worked last, but I still didn't like it much. Okay, so
Do you use other
at the company I was at that did have Tableau, I just used it was an internal tool that they created called Argus, which is also the name of a real estate software. Not that. It's a visualization tool. And the reason that we used that was because it was easy to build pipelines and then build queries that access the data created by those pipelines so that non-data people could use an interactive dashboard, which is something we will talk about, I think, like week 11. Not Argus specifically, but what I just discussed, creating a pipeline and then a dashboard on top of that pipeline. Because, bit of a tangent, but a noteworthy one. One of the biggest things when you're the data scientist somewhere is people asking you for reporting all the time. So the faster you can automate that process and give them a tool so they can find their own reported values, the better your life will get exponentially. Because that means you have more time to do actual research and progress things, and less time putting out fires to answer questions. So if there's anything I could say, it's very much get on top of the creating dashboards and reporting game. Okay. And this is just going to make a nice scatter. So we can do a scatter matrix, which again takes 3 values or 3 dimensions and then scatters them all against each other and produces a nice grid as an output, right? Pretty neat. So you'll note that a couple of things happen. The first is, why do we have these histograms in the middle? Why do we have that?
Well, you can't scatter the distribution of the value against itself.
Well, yeah.
Maybe it wouldn't be historically closely because follow that of that
Right. If we scattered a value against itself, what's it going to look like? Straight line from the 0, 0, 45 degrees out. So Pandas is like, that's not valuable. I'm going to go ahead and give you a histogram. And you're like, thanks. And then
So, how is this different from the Seaborn's Barplot? It seems very similar right now.
it is quite similar. We'll do pair plots. The difference is pair plot. Does Seaborn automatically know to do histograms as well? Yeah. Then I guess it's the exact same.
So that's just a matter of preference in terms of
Yeah.
in terms of visualization. color.
Yeah. I think. Yeah. And actually, in fact, there's something in Seaborn we'll discuss. We'll do a pair plot, and we can even do it at the same values and look at it. It'll be the same. But then there's something else called a correlation matrix that is uniquely valuable about Seaborn that I cannot do in this. The second thing is, what do you notice about adjacent corners? Or what about the lower left hand and the upper right hand? So like this plot, how does that look compared to this plot?
Pretty much inverted.
Yeah, we just inverted the axes. And this is like a good, like, wow, visualization can really change the way we look at data moment, because those plots actually look quite different. I mean, of course, you still have a clustering around 0, 0, but inherently subjective, this one looks like it's showing a bit maybe of a better relationship when it's put like that than the one down here. And it's the same exact data. Okay. So now we've done histograms. Now we're going to do bar plots. What's a bar plot? Yeah, it's a histogram, but allows us to do categorical variables. And because of that, doesn't need to be continuously distributed. So I'm just going to show how many continents of each we have. And then we're going to plot exactly this thing you just saw here, the value counts of continents. The plot kind is called bar. So there you go. Pretty straightforward. And then we could do the same thing where you guys do group bys much yet? 100% should love group by. It allows you to, as its name would imply, kind of like an if statement where if one column is this, then use all those data or all those points for the next thing I'm going to tell you to do. So for this, all continents, and the mean for that continent. It's like an implicit if statement. I mean, even simpler way to think about it, but it just uses the name and the definition. It groups, right?
Is that kind of like a pivot table that's on the fly?
Yeah. It's just like a table on the fly. So here we did a bar plot, and we did the means of each continent on our bar plot. Cool. What do you notice about this bar plot, though? Europe drinks a lot.
Still has leaders.
So has leaders. Why is that a problem, though?
That's not a type of,
Yeah.
one of these things is not like the others.
Yeah. Not only is it not like the others, but
Messing with the scale.
right. Well, it's not messing with the scale. It just makes it worthless to have it. In other words, leaders is measured
this is measured differently than all of these. This is liters of pure alcohol, remember? And this is like aggregate consumption of beer. I have an exact unit of observation. Right. Yeah, I think it was servings. It was servings. You're right. So that's skewing our data.
So we can do the same thing and drop liters. So it's the same exact line of code, except after the mean. So this line of code says this data frame, group by continent, find the mean for each of those continents. And I found, so right now at this stage, it has the mean of wine, alcohol, or wine, beer, and the other one, spirits. I feel like Rick Perry. And you drop liters, because liters was there too, and then you plot it. And that's nicer. And if you are a journalist that doesn't know data, this is really important. If you want to misrepresent data and make a horrendous visualization, it's critical that you know how to do this. You can do these, and then you could stack them on top of each other, right? So in other words, you can make it really hard to tell the difference of how big one is versus another, because they would all be on different values. And you see these all the time, and it drives me nuts.
So you would say just never do that?
I would, but I mean, unless you have a very unique reason that this is a more valuable representation of something you're looking at. There's one good example I've seen ever, and it was a WSJ story that was comparing living costs across cities. And one of their values was something like rents, which is very similar across New York, DC, and San Francisco. And because of that, they all kind of started from the same baseline. And then you can see the differing, the other features were very minimal. You can see the differing like healthcare costs, childcare costs, and so on. And so it contrasted and exacerbated the differences in the other features and costs of living in those cities. And that is the one example I've seen that makes sense. Even then, they could have just omit costs of living and then produced a plot like this of every other feature. So even then, they didn't have to do it, but we'll give them a pass. Okay, so who's not familiar with what a box plot is? What does a box plot tell you?
It shows you your interquartile range, your median, your 25% values, and 50% up. And then I think it has whiskers. I'm not sure if that's for outliers or something else.
Yeah, so whiskers go up until every value that's not an outlier, the maximum value that is not an outlier, and then outliers are just dots above it, and the same for the below. So if we have no outliers, we would have no dots above, and the whisker would help us all our data. But yeah.
How does it define an outlier? Is that just like within a certain standard deviation?
If it's outside of the interquartile range times 1.5.
Okay, so the whiskers actually 1.5 outside the 70%.
Yeah.
Okay.
Well,
Because technically,
only if there's a data point.
well, it's just technically, if the outliers are above the whisker can be the next value.
Yeah. Yeah. And I mean, I included a refresher here in the comments. Okay, so we're going to do this for, actually, one other thing is, you guys made violin plots recently. That's a more, debatably, more useful version of a bar plot, because the width of our bar plots also shows the distribution of our values in violin plots. Violin plots are dangerous if you have small data sets, though. Is there questions about that? Okay, so let's go ahead and do some box and whiskers. I'm going to order values. I want to describe them. So this is what we're about to plot, right? 25th, 50th, 75th percentile. There we go. spirit. Now, we could do the same thing for all the variables, but remember, I'm going to drop liters because liters is measured differently and therefore doesn't fit with the rest of our data. So what am I going to see here? Don't run it. Have you run it yet? What am I going to see here? Yeah. And by what? Yeah. Yeah, and that's that for box plots. Pretty straightforward. Now let's do some line stuff, and we're gonna use a fun data set. You guys use the UFO data set? This is an official data set that is public sightings of UFOs in the United States. That makes sense. True.
How often would you say that you're going to use a box plot in the real world to represent something?
They're kind of academic in nature.
Seems like they don't seem too user friendly if it's the first time you see something.
Yeah, they're pretty academic in nature. I just used one because I was doing the thing that was academic in nature, but
Like greatness.
got him. No, yes, but also showing the Airbnb
You wouldn't show
data.
the general population.
What's that?
You wouldn't show the general population of box plot if you're trying to represent some data, right?
Maybe. I mean,
Or problem.
you would not the general population. Yeah, that's safe to say. So yeah, this data set, let's take a look at it real fast. This data set is UFO sightings by city, the colors reported, the shape reported, the state, and the time. So we're going to take that guy, read them on in. And to be clear, when I'm reading this in, I'm doing this inefficiently. I could put the URL where URL is, right? Okay. I'm going to redo my time column so that it is truly a time column using to date time. I'm going to do the same for the year column, except year is going to be to year. Dates are like the worst data type to work with, like across the board.
The year line is something different, that just shows.
It's the, yeah, but this call I like is more efficient to call based and says explicitly only for year rather than taking the time frame. So we could do year.
We like kind of talked about this very briefly. Is it more efficient to work with time and analyze it with what's it, panels or journals as well? Like really? Yeah, panels. Like have you do much of that with pandas, or is that just like level of complexity?
I don't know. I don't work with a lot of data sometimes. Usually what I do is I end up just parsing it to a way that makes sense for me. But I don't have a great answer for you about if that's a common way. Yeah. So I'm going to sort my years. I can now work with my year values because we had them as strings and we just turned them into years, which are workable, like sortable, quantitative values. So now I can plot this. What is this? What did I just plot? Yep. UFO sightings per year over time. It looks like the aliens are getting more active. Very much so.
Or maybe there's a correlation with number of alien TV shows like this.
Okay, here's the best correlation I've seen for UFO sightings. This is important. This is UFO sightings by time. This is working hours, drinking hours.
I also like drinking a thing like that.
All right. Another tip for journalists, future budding journalists. If you're plotting data that has no logical ordering, like for example, data that isn't time over time, you definitely use a line. Lines are a great way to represent data that does not have any logical reason to be value connected. So here's a good example. Here's continent as a line from our drinks data set. So there's no logical reason that Africa connects and goes down to the number of continent observations we had in Europe, etc. Right? Don't do that. Okay, we're going to quickly do group box plots. Just makes it easier for us to do box plots by one variable type. Kind of neat. There you go. Box plot by continent. Okay, and then we're going to do grouped histograms pretty quickly too, because we already know what a histogram is. So just showing you how to group together things is just a logical, easy progression. So remember, this is our drinks data. We can do histogram by beer and continent. And then we can have them share. So the difference between this is grouping continent and beer, all those histograms and what those histograms would look like. And then I said share the x-axis so that we can actually just look vertically and see straight down how values match up or don't. Sometimes, like, use cases for these things are very situationally dependent for obvious reasons, as is all visualization. This is sharing X and Y. And then make them group together. And this just changed the way that they display. Yeah. The last thing that I'm going to say, now you know how to make great, awesome visualizations and how to be a journalist. So you got to save the graphs that you make. And that's just plot.savefig. Provide a name, and then it'll save to your current working directory. And that's where you can find it for future reference. So anything you make goes to the current working directory. Things will overwrite each other if you use the same name. And then that's that. We already did the plots available thing. But that's the basic of exploratory data analysis using visualization. Oh, I was going to show one thing, sorry, in Seaborn that you don't know that would be helpful. Where was I playing around? So import seaborn as SNS, and then you can do something called a correlation matrix with colored by heat map. So what it's going to do is it's going to put every value against another value, and then the correlation coefficient for those two values is going to be darker if it is higher. So for the drinks data set, it's a lot less powerful because we have a pretty small number of columns, but still you can see what things correlate with what other things. And of course, every variable correlates with itself exceptionally well. You would even say 1.0. So wine correlates pretty well with beer. Wine and spirits really don't correlate, etc. These look really pretty when you do them with large data sets. And they show you very quickly inferences that you may want to investigate. Yeah. And that's the one thing in C1 that I was going to show you. As I mentioned, when you asked that question, could we do this in C-Word? And I said yes, but there's one other thing in C-Word. This is it. Right. So yeah, that's this template of just understanding your data, doing the same type of thing per column, isn't super riveting, but is incredibly important to understand your data set. Are there questions?
Maybe not so much the use case, but there's a percent of getting there in terms of being able to do rigorous exploratory data analysis, visualization. What percent would you say they're there after this?
The interesting thing is, this gives you all the tools to, frankly, be there 100%, but the applications you use is what the big gap is. And that just comes with experience of playing around with your data. Like, trying to think of what sorts of things you'd want to know, histogram or things plotted against one another, density plots when those make sense. Visualization is very domain specific. Some things in data science are very removed. This is one that's very informed by your domain expertise. And all the functions here give you the tools that you would need to sufficiently understand, I would say, venture to guess, like any data set. Visualizing it and making it super beautiful is another sense, and there's other technologies you should be using. But in terms of understanding your data, you should be good to go with these tools.
Explain again what it's a right bar. What this color graph is.
Yeah.
Coefficients.
Yes. Okay. The darker it is, the higher the correlation coefficient. So that's why one variable versus itself is the darkest it can be, 1.0, because one increase in one variable is a decrease in itself.
So like that inverse relationships that would essentially go to negative one. So that's what it's here.
Absolute value.
It is.
Yeah, I think. I'm not 100% sure, but I'm pretty sure. The axis, the color map will change with you.
Yeah.
You won't catch you by surprise.
Is this person
Neither. This is just checking how two variables are correlated, which says for a change in x, how much did x2 also change? So it's just like the variances compared. You're not doing any, R squared requires you to be fitting a model and seeing how far you are from one thing to another. We're doing none of that here. It's a good question. Okay, good stuff. I think we have a break and Brian's speaking? At 11, okay. Cool.
You're actually going to.
Yeah, I know I'm going again. But
I think at the moment we've got. As in like